that can be scanned and is available, but there's only a small portion of it that's actually being used, and probably even a smaller part of it is being advertised to consumers as, oh, we're taking advantage of this piece of it. Is that the right model that I have in my head?
Yes. No, yeah, that's correct.
Okay. So it kind of gets to that, like, you only use 10% of your brain type of thing. Well, we're only using X% of the data. Like, what stops us from using the rest?
I see. I gotcha. So basically, we don't know the significance of all the rest. Is the short answer. So you get this, or we do know the significance, and it's just, that's just not what they chose to report on. So I would put it this way. Let's say, a genotyping array has about 1 million markers on it, but you use statistical approaches to expand that out to basically all known common genetic variants in the human population at large, something like 40 million genetic variants. But every individual probably has about 3 million of those, and then of those, that very large collection of genetic variants, only a small number of them on the polygenic side of things, only a small number of them have actually been statistically associated with disease. The issue being that, one, when you're doing these large association studies, you're testing 1 million markers, so that's a lot of statistical tests. So it's hard to get statistical significance when you're doing a bunch of different tests. And the other problem is that the effect size, or like the amount of risk conveyed by each of these genetic variants, is very small. 10% relative risk, meaning like one of these markers, if the population on average is at 10% risk of, let's say, lung cancer, and one of these markers increases your risk by 10%, that's relative 10%. So your risk goes from 10% to 11% instead. So it means like nothing on a single marker level. And that was a controversy around 23andMe, because back when they first started, there was maybe like 5 markers associated with each condition, so you really couldn't stratify people. Now that number has grown to 100 or so per condition, so you can start putting people into these different bins. But again, that's a very small set of markers relative to the overall number of markers in your genome. Now, they're still going to be used for other purposes, right? So like 23andMe is collecting that data plus the survey data, so they can start asking other more like research-oriented questions, try to find other associations with disease, sell that to pharma or develop their own drugs based on new kind of genes linked to different conditions. So it's definitely being used, but in more of a research context than what's actually just being reported out to people. So basically, they're reporting the higher confidence stuff out to consumers, and then using the rest for research purposes.
Excellent. And then if you so you mentioned earlier that you thought like the dietary ones were questionable. So what can you actually learn on that front? You said that like having a couple of genetic markers would be associated with like caffeine and alcohol, like doesn't buy you a whole lot. Like what could you do? So if you were in charge of a kind of genetics and diet interfacing company, like what value would you be able to pull from that?
Yeah, I think the problem. I think the problem with these kind of nutrition sort of things is we all sort of know what we should be eating and what we shouldn't be eating in the first place. So it's hard to see how genetics really adds much to that. I think I think it makes more sense if you're like an elite athlete or something like that, and you really want to optimize like your nutrition levels so you are like at super peak performance. Fine. I could see where knowing about kind of subtle difference